Alrighty, in this video here, we're going to be talking about 9.3, which is determinant and Cramer's rule. Basically, today is just now that we know what matrices are, what are more ways that we can use it to help us solve for our systems? All right, so to find a determinant, these are just our notes. If you're given a matrix, I know they use like A11. I'm just going to use A, B, C, D. Then to find the determinant, that's basically just going to be your AD minus BC. So I'm going to take this diagonal, multiply it, and subtract it by this diagonal. All right? And then that's pretty much it. That's the first part. Then you need to know how to find a minor. A minor is finding the determinant, but you're taking out some rows. So for example, if I wanted to find the minor of A11 and I had a 3 by 3 matrix, I would take out row 1 and row 2 and then find the determinant of that guy. If I wanted to do a cofactor of, let's say, A11, I do the same thing that I just did here, but I also need to do -1 raised to whatever the row plus column is. So row plus column. So in this case, that'd be 1 plus 1 to that determinant of whatever this value is. All right, so that's what cofactor means. Let's see what else we got in here. So determinants. So to find, so that's minor and cofactor, but if I wanted a determinant, this is for a 2 by 2, by the way. For a 3 by 3, I would just take this guy and I would have to do it to each row. So what I want to do is I want to find each row or column that's the most convenient. So for example, if I just, let's call this A, the determinant of this one here would just be, let's say I wanted to do it for this row. It doesn't really matter what we do it for right now, but I would do A11. So I would do the minor for A11. So that would be the determinant of A22, A32, A23, A33, plus, nope, I lied, minus, plus, minus, plus, and this keeps alternating. So it'd be minus A21. This time I would take out this column, so it'd be A12, A13, A32, A33. And I'll show you which one to pick, depending on how many have zeros. And then plus A31. So you don't have to use this one. This is just a way to do it. So you can have something like that or multiple other ways to do it. You can do rows or columns to choose from. And then the big one today is Cramer's rule. For a 2 by 2 matrix, you would find to find the x value, it'd be the determinant of the matrix, or sorry, the determinant of x divided by d, and then y would be the determinant of y over d. So for example, let's say we had a matrix or a system ax plus by equals c, and then dx plus ey equals f. I know the book uses, a, b, 1, 1, all that stuff, but this is the case. So d would simply just be the determinant of a, b, and de. But dx would be the same thing. You're just going to replace the x column with what everything's equal to. So now it's going to be CF and then BE and then DY, same concept. You're just going to replace the Y's with what it's equal to. So this is going to be ACDF. And then you just, once you get those determinants, you just divide it and you have your answer. And that's just for a 2 by 2. You can use Kramer's rule for a 3 by 3 as well. And in this situation, actually, it's infinitely as big as you want it to be, but today you're only be seeing 3 by 3s. You do the same process. So if you had it to, you had to find DZ or something like that, then it would be, to find Z, it'd be DZ over D, right? You just keep that process going, taking out your determinants, taking out your values, and then I'm also going to show that you can row reduce. So you can look at the definition if you like, but I think to find a Kramer's rule by a 3 by 3 might just be easier when I show you an example. All right, so here we go. So let's talk about some examples. Let's look at page 597. We're going to look at number 4. We're just asked to evaluate what the determinant is. So you get 34, -2, 17, and -1. So remember to find the determinant. I need to multiply these two first. So 34 times -1 is -34 minus the product of these guys. So -2 times 17 is actually -34. Two negatives make a positive. So you get 0 as a determinant. All right, and 0 is an answer. All right, let's try 11. 11 is -2, 9, 5, -3. Multiply this diagonal first, so -3 times -2 is 6, minus this diagonal, 9 times 5, which is 45, and you get -39. That's it. All right, let's make it a little bit more interesting. If I give you A is 2, 0, 1, -1, 1, 0, 5, 3, -2, and I ask you on number 23 to find the cofactor of A12. All right, for starters, you'll do -1, and you'll add the row in the column, so 1 plus 2. And then you'll find the determinant of the minor of A12. So that means I'm going to take out row 1, and then I'm going to take out column 2. And then there's my determinant. 0, 3, 1, -2. So 1 plus 2 is 3, so that's -1 to the third power. And then 0 times -2 is 0, minus 3 times 1, which is 3. So -1 to the third power says -1. 0 minus 3 is -3. So -1 times -3 is 3. So that would be what the cofactor of 3 is. Of 1, 2, sorry. Let's look at number 24. Using the same thing, I want you to find the minor of A22. Cofactors, the only time you have to do this, minor, I can go straight into figuring this part out. So I'm going to erase these lines for this next problem. So 2, 2, I would then eliminate row 2 and column 2. So now my determinant here is 2, 5, 1, -2 for the minor. So that's going to be 2 times -2, which is -4, minus 5 times 1, which is 5, which gives me -9. All right, now I'm going to try 39. 39, we're asked to evaluate each of the following determinants. In each case, minimize the required number of computations by carefully choosing a row or column to expand along and use properties of determinants to simplify the process. So we are given 2, 0, 1, -5, 1, 0, 3, -1, 1. What we can do here, since I have zeros, I want to choose a row and column, or a row and a column that is pretty relatively easy. And I'm going to be honest with you, when I look at this, I see this column right here that have two ones and a zero. I'm going to look for the column one, or I'm going to look for a column or row that has the most zeros. But this column, this row, and this row each have 1, 0. So then I'm going to look at their other numbers. And I'm going to go, you know what? This has a 1, -1, but these have two ones. Super easy to multiply by. So I'm going to use this right here. And what I mean by that is this right here is going to be considered, was that A 1, 3? So what happens is when I use this value right here, I'm not going to use that row or that column. So there's my determinant right there. So it's going to be -5, 1, 3, -1. And then we go, it's positive, negative, and then the pattern just keeps going. So this will now be negative. And now what I'm going to do is I'm going to choose 0, which makes it so nice. And I won't use this row or this column. So now that's going to be 2, 0, 3, -1. And I'm going to go plus, and now I'm going to choose this value right here. So that's going to be 1. And now I won't use this row or this column. So now it's going to be 2, 0, -5, 1. What's real nice is that zeroes out, so I don't even have to do that. 1 times this, I just got to figure out what this is. So that's going to be -1 times -5, which is 5 minus 3, plus 1 times this. I just got to figure this out. So 2 times 1 is 2. 0 times -5 is 0. So that means 5 minus 3 is 2, plus 2 gives me 4. So I was able to easily determine a 3 by 3 determinant by picking a specific row or column that had the easiest math. So that's why I said it's hard for me to write that out as a proof unless I show you. All right, so here we go. So let's do Kramer's rule, and then that will pretty much be everything that you see on your homework. So let's look at number 48. 48, you are given 2x minus 3y equals 8, and 8x plus 5y equals -2. All right, according to Kramer, let's go find our determinant, which is without the solution. So that's going to be 2, -3, 8, and 5. I need to go find my dx, which is basically going to replace row of my x's with the solution. So that's going to be 8, -2, and then -3, 5. And then dy, I'm going to replace my row of y's with the solution. That's going to be 8, -2, and then the original x values, 2 and 8. Oop. So now I'm going to find these values. That's going to be 10 minus 3 times 8 is 24. So that's -24. So that makes it a positive. So that's 34. 5 times 8 is 40. Minus 3 times 2 is 6. So that's 34. -2 times 2 is -4. Minus 8 times 8, which is 64. So that's going to be -68. And so therefore, according to Kramer, x is equal to dx over d. So now that I've done all the work, I can just say, well, that's 34 divided by 34, so x is 1. So that's the solution. Why? The answer here would be -68. Oh, is dy over d. So that's going to be -68 over 34, which is -2. So that's the answer. So my answer is 1, -2. I didn't have to do a matrix. I just based it off the determinants using Kramer's rule. All right, let's look at another one. Let's look at number 49. 49 is 5x plus 7y equals 9, and 2x plus 3y equals -7. All right, so again, my d would just be 5, 7, 2, 3. My dx, I'm going to replace my row of x with what it's equal to, so 9, -7, and then 7 and 3. My dy, rewrite my x. I'm going to replace this y with what it's equal to, so 9, -7. All right, so then I just got to solve it. So 5 times 3 is 15, minus 2 times 7, which is 14, which is 1. 3 times 9 is 27, minus 7 times 7 is 49, so it's positive 49. 49 plus 27 73. Ooh, 76. And then this would be negative 7 times 5, which is negative 35, minus 9 times 2, which is 18. So 35 plus 18 will give you negative 53. And so with that, I can see that my x would be dx over d. So that's going to be 76 divided by 1, which is 76. My y is dy over d. So that's going to be negative 53 divided by 1, which is negative 53. So in this case, that's 76 comma negative 53. And with those numbers being that big, I would probably have some big calculations going here. I'm glad I didn't have to do so many of them. Alrighty, one last one. Let's look at a three-dimensional space. So let's look at 54. We have x plus 2y equals negative 1. We have y plus 3z equals 7. And then we have 2x plus 5z equals 21. So Cramer's rule is the same. However, let's rewrite this as a complete matrix so we can see it a little bit better. So this will be 1, 0, 2, 2, 1, 0, 0, 3, 5. And this would equal negative 1, 7, 21. All right, so in this situation, when looking for your d, x, y, and z, when I'm looking for d, I can just, best way to do this is just find my determinant of 1, 2, 0, 0, 1, 3, 2, 0, 5. dx, I'm going to replace row 1 with what it's equal to, so negative 1, 7, 21, 2, 1, 0, 0, 3, 5. dy would be 1, 0, 2, replace y now with negative 1, 7, 21, 0, 3, 5. And then dz would be 1, 0, 2, 2, 1, 0. Now I'm going to replace that z with negative 1, z, 21. All right. Before I work on that, I want to find out what's my best row or column. So this, I think I have. No, that won't work. Yeah, I'm looking at this and it's either 102 or 120 will be your easiest one. So I think I'm going to use this. So that's going to be 1. I won't use this part. I won't use row 1 or column 1. So that's going to be 1, 3, 0, 5 minus 2. So I won't use this row or this column. So that's going to be 0, 2, 3, 5 plus 0. And I won't use row 1 or column 3. So that's going to be 0, 1, 2, 0. That zeroes out. So that's nice. This will then become see, it's going to be 1 times 5, 3 times 0, so 5 minus 0, that's going to be 5. Minus, that's going to be 0 minus 3 or 6, so that's going to be negative 6. So that's going to be 12 plus 5, which is 17. Alrighty. Yeah, I think this 210 right here is going to be your best bet. So I'm going to use 2. I won't use that, so that'd be 7, 21, 3, 5 minus 1. So that's going to be negative 1, 0, 21, 5 plus 0, which is 7, 1, 21, 0. That goes away. That gives me 2, 35 minus 63 minus -5, because I don't want to be zeroed out. 35 minus 63, -28 times 2, -56, plus 5 gives me -51. This one here, I think this one might be the easier one this go around. That's going to be 1 times 721.35 minus -1. So that makes it a plus there. Would be 0.325 plus 0.07221. That zero out. So that'd give me 5 times 7, which is 35, minus 21 times 3, which is 63. Plus, because that's what two negatives are going to make, it's going to be 0 minus 6. So again, that was 35 minus 63 minus 6 gives me -34. And then here, 102,210. Well, I'll go this way. I don't think it really matters. So it's going to be 2 times 0.2721 minus 1. And it would be 1, -1, 221 plus 0. And that would be 1, 0, -1, 7. So that will go away here. So then I get 2 times -14, because 0 times 21 is 0, minus 14, minus 21 minus -2, so that's +2. Okay, so that's going to be 14 negative times 2 minus 23, which is -51. All right, now to finish this answer, x is equal to dx over d. So in this case, that'd be -51 over 17, which is -3. Y would equal dy over d. So in this case, that would be -34 over 17, which is -2. And then z would be dz over d, which would be -51 over 17, which is -3. I got negatives across the board, but my notes here say it's actually positive, negative, positive. So that would mean let's check it. That'd be -3. Yeah, -3 and -4 do not make -1. So I definitely went astray here. So see, I got my 1, 2, 0. So I used 1, 3, 0, 5. That would be 5. And I used 2. And I used 0, 3, 2, 5. And that would be negative. So 5 minus 2 minus 6, which makes it positive 12. So that looks good. So then I did 2, 1, 0. I think I might have misjudged something. That's what it is. All right, so I assumed it was positive minus positive every single time, but it actually goes like this. So we need to write this as a note, just in case you run into this. So it's actually positive, negative, dot, 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 negative, positive, dot, 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 positive, dot, 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 negative, positive, dot, 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 positive, dot, 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 dot. So that means when I pick this one's correct. When I pick this one should have been negative. This should have been positive. This should have been negative. This one's good, but then this one should have been negative. This one should have been positive. This one should have been negative according to our chart. So what happens is this ends up being negative, and this ends up being positive, and then this one's good. And then this one ends up being negative and then positive. So let's just re-add those. So negative, so 35 minus 63 times negative 2 gives me 56. Minus 5 is positive 51. And then over here, I'd get 28 plus 23, which is positive 51. So make those positives, and these become positive. So that's it. So that was a good, I'm glad we ran into that. So 3, negative 2, 3. All right, and that's all I got there. So if you have questions or need more explaining there, just email me and let me know. Other than that, that's all that I have for today. See you in the next one. Bye for now.